So guys, see on the screen there is question number 16. Question number 16 is there on the screen. Okay. Now all the questions are very simple. Actually, only one thing which you need to work. You need to work in this one. This is more. I think this question is still more simple. A friction cone clutch. See, as I said, no, in the previous classes, there is no type 1, type 2, type 3 problems here. So everything is one. Some data is not given. We know the equations, which equations we are going to use it. Here, I have already explained. This is the equation. These are the equations. Only see, let it be. It is only two equations which I am using it. Okay. To support these equations, I have a few more equations. To support these equations, I have few more equations. Other than just no other equations which we are trying to use it. So in question number 16, the same thing which we are working. A friction cone clutch must transmit a torque of 200 Newton meter. So once again, question number 16, which we'll be trying to write. Given data, let me write the given data here. Okay, the torque MT 200 Newton meter. So will be equal to 200 into 10 power of 3 Newton m. This is the data which has been given. Okay, at 1440 rpm, small m 1440 rpm. He has given this data also, and he has given the diameter. He has given the diameter. The larger diameter of the cone is 350 mm. So once again, D2 350 mm. Larger diameter of the cone is 350 mm. And he has given what else? He has given the cone pitch angle. The cone pitch angle is nothing but your alpha. Okay, 6.25 degrees alpha. The face width is 65 mm. B 65 mm. So all the data is given. The coefficient of friction is mu. Mu is equal to 0.2. Determine the axial force required to transmit the torque Fa. Determine Fa. The average nominal pressure on the surfaces on the sorry, there may be a spelling mistake, on the contact surfaces. It should be contact surfaces when the maximum torque is transmitted. So he's expecting me to find pressure also. Expecting me to find the pressure on the contact surfaces. Okay, when the maximum torque is transmitted. This is the data given, guys. So how do you solve this data? Tilak, mute yourself. So this is the data which has been given.
Yes, sir.
So how do we solve this numerical? Try to see here now. So torque he has given, speed he has given. So your first step, as usual, you start thinking of your first step. Okay, so the first step in this case is torque MT to find the this one power. Is it important to find the power here? Because FA, do you have a power requirement for in FA? I don't think so. There is a power requirement. You should see. Try to see here. In FA equation is pi dm pb sin alpha. Our torque equation is mu FA dm by 2 sin alpha. So there is no requirement of capital N. There is no point of finding the power. Only MT is important. Small n 1440 rpm. I don't think so. It will be used at all in this numerical. There is no point of using. But study has given it. Not an issue there. Let me start with this D2 one, guys. Because most important thing is, yes, this is what exactly has given D2 and B. Okay. Now one thing we know that can you remember this? The D2 is equal to dm plus B sin alpha. Sin alpha. This is the formula which we have. D2 is equal to dm plus B sin alpha. So value of D2 is given, value of B is known, value of alpha is known. From this equation directly I will be getting the value of dm. We'll be getting the value of dm here. So once again substitute this. 350 will be is equal to dm plus B is 65 multiplied by sin 6.25. How much? How much is the value of D?
342.9, approximately 343 mm.
343. So I got this value of dm, 343 mm. Very simple way. So for your first step is done. Now directly I'll go with finding FA. Now finding FA, from where we have equation, let me write both the equations and we'll choose one equation. FA is equal to, we have equation pi dm pb sin alpha. Okay, this is equation number 19.75, and there is one more equation. Torque is equal to mu Fa dm divided by 2 sin alpha. Okay, now this equation is equation number 19.78. Which equation should we use, guys? If for 19.75 or 19.78? 78, because torque is also known now. So we go for equation number 19.78. Okay, and I forgot, students, if you feel that the screen is very small, I heard that for students you have option of zooming in your mobile phone, it seems. I think in your mobile phone you can zoom this, so you can be more clarity will be there. So coming back to this empty, we have given the value, or if we use this equation, this empty equation. So once again, 200 into 10 power of 3 is equal to mu has been given 0.22. 0.2 Fa is unknown. Dm we have found 343 divided by 2 sine 6.5. Very simple. So you end up in finding Fa. How much?
634.7.
634.7 newtons. So we have got this. Now I'll use this equation. Fa is equal to pi dm pb sin alpha. So I'll be using I'll be trying to find the value of p here. So once again, 634.7 is equal to pi into dm. Dm is nothing but diameter 343. Okay, 343 mm is the diameter, and what do you have into p? So p, let me not write this, into b is 65 sine 6.5. How much is the value of p?
0.08.
0.083. 83. 1 minute. Your problem is done. You have solved question number 16. That's it. You don't have much to work on this. So you have solved question number 16. This is what we will be trying to do in question number 16. So let us go with question number 17. Any questions you can ask? Any questions you can ask? Okay. So you have question number 17 on the screen. This is also a very simple question, it seems to be, but he has asked design the clutch. Design the clutch means every parameter which you need to design, the dimensions of the clutch which you are supposed to design it. Okay, an engine clutch. So let me write it for you. Okay, so there is something called as an engine developing 30 kilowatts. So he has given speed. Quickly, I want you to work on this. So question number 17. Question number 17. The engine developing 30 kilowatts. So once again, power, capital N is 30 kilowatts. 30 kilowatts at 1050 rpm. Small n 1250 rpm. Is fitted with a cone clutch. The cone has a face angle of 12.5 degrees, alpha 12.5 degrees. I have already told in the starting classes saying that this semi-cone angle is also called as face angle or also called as pitch angle. So the mean diameter is 400 mm, dm is equal to 400 mm, mu 0.3, mu is 0.3, and the normal pressure is not to exceed 0.08 Newton per mm square. So pressure is equal to 0.08 Newton per mm square. Design the clutch. What we are supposed to do is the entire design of a clutch which we are supposed to do it. Design the clutch. So once again, as I keep on saying it, your talent lies in understanding the question, guys. I'm clearly saying that 50% of your problems will be solved once you have properly understood the question. Okay, once you have properly understood the question, write the given data, 50% of the things is solved. Now applying the equations is remaining 25%. Okay, and the solving is last 25% of your work. Applying the right equations, the right time is what exactly it is required for you. So the problem is very simple in this case. Torque empty. Let me. I want your quick answers now. 9.55 into 10 power of 6 into capital N by small n. So he has given the value. He has given the value of small n and capital N. Capital N is 30. Small n is 1250. So tell me the answer, man.
229200, sir.
229200. Right. Newton. Right. I have your answer. Next immediate thing is FA. Next immediate thing is FA. FA is equal to pi dm pb sin alpha. Sin alpha, which will be trying to solve. So once again will be equal to the value of what exactly you will be trying to find. You will be finding the value of FA. Everything is given here now. Try to substitute back. Everything is given. So here dm is given as 400. P as given as 0.08. B value he has not given. No, B has value has not given. Yes, try to understand. So I don't have B, but alpha I have 12.5. So obviously I cannot use this equation. So I have two unknowns. We cannot use this equation. Let me find FA and come back to B. Let me find FA and come back to B. So this equation I will not use. Instead we will be trying to use the next equation. This is what exactly we will be trying to do in the external examination. Use each equation. You see if the unknowns are there, then you shift it to next equation. So empty is equal to mu FA dm by 2 sin alpha. So obviously this is equation number 19.78. Now in this equation all the data is there. So once again try to find it down fast. So empty just now we have found 229200, mu 0.3, dm 400, alpha 12.5. So what is the value of FA?
826.7, sir.
826.79.
79. Yes, sir.
8 meters. 826.8 meters. You got the value of FA. Once you got this value of MT, now use this equation FA. Once again, we'll be trying to use this equation FA. So FA is equal to pi dm pb sin alpha. Now here we are going to find the value of B. So first start finding the value of B now. Okay. Now FA is 826.8, dm 400, pressure 0.08, alpha is
7.96, sir.
how much? B is equal to
38, sir.
37.
38. B is equal to 38. Done. You are done with your B. Now once you have said, obviously said design the clutch. Design the clutch means that process will be there as usual. DM you have got D1. D1 is equal to DM minus B sin alpha. So tell me the answers. D2 is equal to DM plus B sin alpha. This is the answer which you will be trying to find. Okay. So once again, literally this one. Tell me what is the value of D1 and D2.
D1 is 391.77.
391.77. Okay, let me take this 392 mm then.
Sir, 408.
408.2. So 400, because 392 plus 400 will 408 will be average. If I take it, it will be 400. Because this by default it is assuming uniform weight theory. Since no theory is asked, it is 392 plus 408 by 2 will be your 400, which is whose value will be nothing but your DM. So then if required, guys, try to find the diameter also. The diameter of the clutch D is equal to, but I'll be sharing my notes today. In my notes, sometimes I would have not done this diameter value, diameter of the clutch, because always I feel somewhere that shaft is not a part of the clutch. Shaft is once again a separate transmission element. But still, yes, some books they do it. And since you know the equation, you can solve it. So try to find the diameter of the clutch also by using this equation. Cube root of
3.5.
yes, 16 mt divided by pi tau s eta. How much?
35 will get, sir, according to table.
5
30.51 will get, so approximating it to 35.
35, right. 35 mm from table 14.6. And most important thing is actually after doing everything, what is that is the summary is most important. What you do is write down once again the dimensions of the clutch, then write down the values. D1 is equal to, D2 is equal to, dm is equal to, small d is equal to, b equal to, fa is equal to. This is the right answer, because in clutches there is no wrong answers. If you follow the procedure by default, you will end in the right answers only. And this is the guarantee questions. There is no point that you will be trying to do this. And do you know one more thing? This is one of the easiest part, and every chapter will be something like this only. You follow me sincerely and you work on this, you continuously attend the classes, I'll ensure that this design will be easy. And always there is a notion, guys, it is something like your seniors, they always feel that it is design 2 which is always tough. And after maybe I'm trying to take this design after 3 or 4 years. Before, when Krishna Rao sir was there, Krishna Rao sir used to handle for both the sections. Okay, I used to handle only design. I used to shift it to some other subject because so many other subjects were there for me. And last time, unfortunately, that your seniors, fortunate or unfortunate, they have escaped this writing this test design, because that is because of COVID. Okay, that is what exactly happened. But for you, it is not the case. And you can ask your seniors. They always feel that design 2. They feel that design 2 is tough compared to all the other subjects. But sincerely speaking, guys, design 2 is most easiest subject. The reason is, at least in design 1, you need to use some of your logic, your mindset, which you need to use. You need to think which equation what. Here there is no logic at all. Everything copied from the diagram. 3-4 equations are there. You need to use your equations here and there. That's it. Got it. So guys, be with me. I'll ensure that design 2 will be the most easiest part. So this is once again. I'm trying to handle this design 2 after 5 or 6 years. After 6 years, I'm handling design 2 in this in your college. And because once Krishna Rao sir came, he started for both the sections. So not an issue with this. This is most easiest topic. Don't go with your seniors. Only one thing I expect from you is your hard work. I want you to work more hard and more sincerely with this. Okay, and be sincere to my classes. That is one of the reasons why I am very strict while taking the classes. So guys, let me go with next question. Question number 18. So there is question number 18. Question number 18, which clearly says, now this is also one of the small typical question where exactly he has given certain data. Determine the dimensions of simple clone clutch. Question 18, let me write it for you. Question 18. Determine the dimensions of simple clone clutch to transfer 20 kilowatts. Capital N, 20 kilowatts at 1000 rpm. Small n, 1000 rpm. Small n, 1000 rpm. The minimum diameter is to be 300 mm. What is this? Can you tell me?
D1.
D1 300 mm. D1 300 mm. Okay. Transfer is 100 mm and the cone angle is 20 degrees. Alpha 20 degrees. Is it alpha or 2 alpha?
2 alpha.
Right. It is 2 alpha. It is not the cone or semi-cone angle. He said the cone angle. So it means that alpha is equal to 10 degrees. Alpha is equal to 10 degrees. Now, and assume mu is equal to 0.2. Mu is equal to 0.2. Okay, and the permissible pressure P is equal to 0.1 Newton per mm square. Okay. Also determine the axial force required to engage the clutch. So axial force Fa also he is asking me to determine during the engage. While rotating also we will try to find how much is the axial force. So this is what exactly we will be trying to solve it. Now this time he has given the value of D1. So there is no point of, whenever I said no, the value of D1, D2 has been given or B has been given, there is no point of assuming D1 by B is equal to 6. So such assumptions we don't make anymore. So how do we start this numerical? Start with as usual empty. So empty is equal to 9.55 into 10 power of 6 into capital N by small n. So how much man? Capital N
191,000.
191,000 Newton and okay, MT is done. Then I'll go for FA. Now let me go for FA. Now try to see here. Before I go for FA, okay, I'll write the equation of FA, but will not substitute anything. dm/bp/b sin alpha. Now try to see this equation. Equation 19.75. Let me show you what exactly is this equation. What happens in this case? FA is not known. FA is unknown. Value of dm is unknown. Value of b is unknown. Three values were unknown. But usually in the other problems, what we used to do is we assume that dm is equal to, or dm by b is equal to 6, and we used to solve. But in this numerical, you cannot assume the same thing also. Can you tell me the reason why you cannot assume?
D1 is given.
Great. D1 is given here. The value of D1 is given. So don't try to assume. Unnecessarily, don't use that tool saying that dm by b is equal to 6. We cannot assume here. Since what we will try to do in this case, we'll try to go with the same notation, obviously, same concept. Okay, we'll go with something like D1. We know that. We know the concept. D1 is equal to dm minus b sin alpha. Well, let me substitute this values of relation between dm and b, so that I will be substituting the relation. See what we used to do. I need a relation between dm and b, so we will get the relation from here. So d1 here is given as 300. So dm minus b sin 10 degrees. So once again you have got this value. So once again, in this case I can directly write it, saying that b into sin 10 degrees. Okay, if I take this, can I say that dm minus 300? Yes or no? I am taking this entire value itself, b sin alpha. B sin alpha is nothing but dm minus 300. So let this value be as it is. Now I'll go back with FA. I need the relation between dm and b. That's it. You can substitute 10 also. Sin 10 in one substitute, you can divide all things. Now let me go for FA. FA is equal to pi dm p b sin alpha. So once again, pi FA, even we do not know the value of FA multiplied by dm multiplied by p 0.1 into what is b sin alpha. B sin alpha can I write it as dm minus 300. Okay, because I have got here bm minus 300. Now once again, what is FA? Multiply this. What is FA? So 3.14 into 0.1, 0.314. 0.314 dm into dm minus 300. Very simple way which we have got. Now what is the next step? I will be trying to find MT. MT is equal to mu FA dm by 2 sin alpha, which implies, so obviously I got 191,000. Mu, how much he has given? Mu 0.2. FA is 0.314 dm into dm minus 300. Once again multiply by dm divided by 2 sin 10. So here I can get the value of dm. Can you tell me now what is the value of dm now? You take these values on the other side. You solve this. So if I take these values on the other side, let me calculate. 191,000 multiplied by 2 multiplied by sin 10. So you have under divided by 2.2 divided by 0.314. Right. So this I am taking down these were two values. So you have what 1056267.578 is equal to dm square into dm minus 300. So you have a cubic equation, guys. You have a cubic equation. 1056267.578 is equal to dm cube minus 300 dm square. 300 dm square. So what is the value of dm now? dm cube minus 300 dm square minus 1056267.578 is equal to, so the dm, how much is the value of dm? How much is the value of dm in your calculators? Can you tell me the answers quickly? Not
287.19.
You usually get two answers, na? dm only cube root, na? Only one answer you get. How much? 2?
67.37.
Everyone are getting the same answers?
301.16.
301. Even I got this obviously cubic equation. So we're online. I can do this. I hope you are seeing this. This one usually so I have the equation here. I think I can solve this equation online itself. What is the value of A? A is 1. B is minus 300. D is A, B, C. A, B, C, C. D is given here. C is given. This one is not secure. Okay. C is 0 and D is minus 1056267.
310.92.
How much?
310.92, and second one is complex numbers.
Very good. Yes. What you said is true. Right. See, 310.92 and next one is complex number. Right. Beautiful answer. So you have this answer. So 310.92 is the right answer, guys. But unfortunately, you cannot use computers there. But you should know how to work on the calculators. And kindly, if you do not know, nothing wrong. Try to take the help from your friend. Okay, who is able to solve this? Because most important in external examination, which you are supposed to work. 310.92. This is the right way of doing it. So 310.92. 310.92. Okay, once you have got this value of dm, now I'll go for all this because he said the remaining dimensions are really simple. Fa is equal to 0.314 dm into dm minus 300. Okay, now I'll be substituting. Can you tell me now what is the value of Fa? 314 into 310.92 into, okay, I can say 311 only, 311 mm. So 311.00 minus 311 minus 300. How much is the value of Fa?
1066.1.
No, 311 I am using.
Okay.
311. Use 311 only.
1074.
1074.19
0.19.
Okay, I got this value of Fa. Now all the other dimensions now, as usual, all the other dimensions which you will be trying to work on this. So after Fa, you try to find the value of B. Okay, I will try to change the page now for a moment. After Fa, you work on this value of B. B is equal to, now we know that B is sine alpha. That is what we have got. What we have got, B sine alpha sine 10 is equal to dm minus 300. So once again is equal to dm minus 300. That is what we have got. So B into sine 10 is equal to 311 minus 300. So can you tell me what is the value of B now?
64 mm.
64. So you got the value of B also, you are done beautifully. Now what will be the thing which is left? So D1 and D2. So remaining other dimensions are D1 and D2. So let me write D1 is equal to dm minus B sine alpha. B is sine alpha. So how much?
D1 is given.
D1 is given.
Okay. D1 is given now 300 mm. Fine. And D2. D2 is dm plus d sin alpha. How much? And d1 plus d2 by 2 also, from there also you can use it. Here also you can use it. You use this equation also, d2 plus d1 by 2 is equal to dm. From this equation also you can use it. What is the value of
322, sir. 322.1.
322? Yeah. So either the equations are okay for you. So you have got these values. Now what you do is you finally write the dimension of the clutch. Then later we'll find once again FA. Dimensions of the clutch. Okay. D1 300 mm, which is given. D2 322 mm, and you have got DM 311 mm. You have B 64 mm, and most important is FA 1074.194 newtons. Now here when you are doing it, okay, when we are trying to solve this part, try to see this question is, he says also determine the axial force required to engage the clutch. What does he mean to say here is, once again find when it is rotating what is the force required. That is what he is expecting us to solve. So once again we will be trying to find the axial force when it is rotating. Axial force for engagement. So because this FA is total axial, maximum axial force which is required. So for engaging the clutch, okay, how much is axial when it is rotating, or how much is it? Because there when it is moving more axial force is required for engaging the clutch while it is rotating. Clutch while rotating. So you have the formula FA dash is equal to Fn into sin alpha plus mu cos alpha. Okay, this is equation number 19.80. You have the equation 19.80. Now once again what we will be trying to do, FA dash Fn you will find. Fn is equal to FA by sin alpha. FA by sin alpha. So you have got FA 1074.194 divided by sin 10. How much is the answer is?
6186.01 Newton.
Yes. So FA dash 6186.01 multiplied by sin 10 plus mu how much? 0.2 cos 10. So how much FA dash? FA dash. Let me know. How much is the answer, man?
$2292.59 newtons.
2292.598 newtons, right. So this is your question number 18, and let me solve this question number 19 quickly. And yeah, one more question which I have left it for you. Kept it for you, right? Good. So question number 19, man. Let me change this. I did. Okay. So question number 19 you have here. New page. So question number 19, it says a cone clutch. This is also a very simple question. A cone clutch has a semicone angle of 115 degrees. Okay, that I need to write it. So semicone angle. So question number 9, I will be giving writing the data. See if there is any difficulty, we will do it. Else we will write only the formulas and we will link down. A cone clutch has a semicone angle of 15 degrees. Semicone angle alpha is equal to 15 degrees. Then and is used to transfer 10 kilowatts. So capital N 10 kilowatts at 1500 rpm. N is equal to 1500 rpm. We have got here the width of the face is 1/4 the mean diameter. What does it mean?
B equals dm by 4.
B is equal to dm by 4. Okay. The normal intensity of the pressure between the contact surfaces 0.12. So P is equal to 0.12. I think we have already solved such type of problem. And the coefficient of friction is 0.2. Mu is equal to 0.2. Assuming uniform wear. So design the clutch dimensions. Take C40 steel and factor of safety 2.5. So C40 steel material is given. Material, which material is? Material of what? Material of shaft C40, and we had a habit of taking 3 as a factor of safety. He has asked us to take 2.5 as a factor of safety. That is the only difference. So hope you can solve this problem. So one last time, what I'll be trying to do is I'll be writing all the equations of this problem. Okay. All the equations of the problem I'll be writing it. I may not solve this problem. I'll write all the equations so that you can realize how the cone clutch will be solved. Okay, so one final equations. Later I'll go for last question number 20. So the equations, if you want to find, you have got empty. Your first equation 9.55 into 10 to the 6 into capital N by small n. This is your first equation. Okay, where N will be always in kilowatts. N will be in kilowatts and small n will be in RPM. Speed will be in RPM. Okay, you and this MT will be in Newton mm. This is your this one. From here we will be finding the MT. Now next equation, since he has given this one, will C40 steel, D is equal to 16 MT divided by pi tau s eta. So cube root of this equation. So you will end up in finding the value of D. And here assume this values of tau s. Tau s is not 54.76 anymore. You need to use divided by this one. So if you want this is 0.5 times of sigma, and sigma is sigma y by FOS, and sigma y is for C40 is 328.6 megapascals. So from where you will be getting the value of sigma, this one, and this I'll be assuming as 0.5. The next equation which we'll be trying to use in this case is FA. The third equation, pi dm p b sin alpha. This is the equation which we'll be trying to use. Equation number 19.75. So that equation here he has given this value. He says that okay, b is equal to dm by 4. So that you have the relation dm is equal to 4b. dm is equal to 4b. Use this relation here. Let the answer be in the relation. Then go for torque. MT. So mu FA Tm 2 sin alpha. Now here also use the same relation. Now in such cases you will be able to find FA here. You will be finding this B value here. Once you get this value of B, because torque you have already found here. Now you will find this values. Now other equations which you will be using, dm is equal to dm minus B sin alpha. D2 is equal to dm plus B sin alpha. Okay. Now then design the clutch, you finish it off. You write it out, value of D1, value of D2, value of dm, value of B, value of FA. This is how we will be trying to solve the problem. What I will try to do is I will write the answers for you. Okay. So that you can cross check your answers at the later stage. So you have this value of D1 178 mm, D2 is 200 mm. So by default dm would be 189 mm, B 47.25, and you have got FA 871.145 newtons. This is your answers. So for this numerical, this is your answers. The answers. So kindly make note of this answer so that you can solve this as once again the assignment or regular notes you solve it. So this is how this problem. So any problem you take, any question paper. Now do you know one thing, at this point of time you will be able to solve any question in your external examinations, especially external examinations of VTU. Any questions in national examinations of VTU you will be able to solve. Right? Any questions till now? Any questions? Right. So if you have any questions, you can ask me. And guys, one more last question I will try to solve, even though 12:55. Kindly bear with me. One small question which I want to solve for you. Okay. 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 Now try to see question number 20. Yes. So this is question number 20. Very large, very big question which I have kept it separately for you. As I know just now, you will be able to solve any question from your B2 examination point of view, but not. Don't think that you will be able to solve all the questions of clutch, because there is a point here. Few things which we need to go over this. I'll be sharing my notes where I'll be trying to give you the derivation part also, derivation part of the clutch also, where the concept is very much important here. Okay, and this question number 20 is not a part of the concept, but still what exactly happens is there are some basics which you need to know, which I thought of sharing. This is from some other university question paper, not VTU question paper. I have got some questions from other university also on the clutches. Now try to see how exactly it happens. A cone clutch is used to connect an electric motor. He says he want to use a cone clutch to connect an electric motor. Okay, question number 20. Carefully observe this question number 20. Okay, because this is most important. This one. Electric motor running at 2880 RPM. So small n here is given 2880 RPM. So motor is running in this with a mission which is stationary. So with the mission which is stationary, you want to connect it. Okay, electric motor and run the mission. That is what you want to see. The mission is equal to a rotor of 300 kgs. So the weight of the mission is trying to talk about. So it is saying that indirectly he is saying that the mission is equal to so much weight. Indirectly he is saying that the flywheel, let me say the clutch is coupled to the flywheel, right? See, when you are trying to connect the motor to this, the basic concept is in this example he says there is a mission, there is a rotor in the mission. I can say that okay, there is a mission is here. Okay, there is a rotor, guys. There is a rotor, and this is some big mission. It can be your sugarcane juice mission. Basically, understand that. So this is a mission, guys. This is a mission, and there is a rotor on the mission. You take this as a flywheel. What this fellow wants to do? There is an electric motor. There is a electric motor. So basically, understand. See, clutches, don't think that always in your automobiles. Okay, there is a electric motor. There is a electric motor, which is going to run at 2888. Okay. Now this motor, he wants to connect this motor to this mission. He wants to connect this motor to the mission. Okay. Now he says that the mission is equal to a rotor of 300 kg mass and radius of gyration as 125 mm. See, mass here is given 300 kg and radius of gyration, usually K. We call this as K, 125 mm. Remember this. I'll tell you what is the radius of gyration. This is very basics of your MOM, which I'm trying to talk about. Your basics of elements of civil engineering from COM, all these concepts would have come. The mission has to be brought to the full speed of 2880 RPM from stationary condition in 40 seconds. So as soon as I do it, I want this mission to run at 2880 RPM within 40 seconds. You should run. So here you want to couple it. You want to couple with a clutch. Okay, you want to couple with a clutch. So this is he wants to couple with this clutch here. So there is a clutch which he wants to use it. There is a clutch which he wants to use it. This he wants to couple it, but as soon as it couples it, it says that within 40 seconds. Within 40 seconds, he wants the speed to be 0 because mission is stationary now. 0 to 2880 RPM, you should come in 40 seconds. You should come in 40 seconds, the speed should be reached. Or you can say that in a race car also this can be possible. As soon as I engage the clutch, within less time I should have a very high speeds. This is the concept. I want this K as, that is what he says. So the time he has given to me is 40 seconds. In 40 seconds, I want the speed to be 0 to 2880 RPM. to 0 to 2880 rpm. Okay, from the stationary condition, the semi-cone angle is 12.5 degrees. So once again, alpha is equal to 12.5 degrees. Alpha is equal to 12.5 degrees. The mean radius of the clutch is twice the face width. Can you tell me what does it mean? Mean radius of the clutch is twice the face width. What is the mean radius?
dm equals 2b.
Mean radius was RM.
dm.
Radius,
rm.
RM is equal to twice the face width. So this 2b. So it means that dm by 2 is equal to 2b. So implies dm is equal to 4b. So he has given this. The coefficient of friction is 0.2. Mu is equal to 0.2. The coefficient of friction is 0.2. And the normal intensity of the pressure between the contacting surfaces should not exceed 0.1. So he says that P is equal to 0.1 Newton per mm square. Okay, assuming uniform wear criteria, determine the face width of the friction lining. So obviously he is expecting me to determine the value of B. Okay, inner and outer diameter of friction surfaces. So as usual, D1 and D2, and force required to engage the clutch, FA. Okay, this is the data what exactly we will be trying to work on this. So try to understand this concept, but this is more real time. All this, see, when you go to GATE examination also, when you are trying to solve it, so such questions you will be expecting. All the questions where exactly we will be trying to do it. Okay. So these are the questions which is been expected. The real time. How do I approach this problem? Usually we have a notion. See, how do I know this? Basically, what should I do now? What should I do with these values? M and K. Okay. Now, basically, if at all you solve the problem, we start with MT is equal to 9.55 into 10 power of 6 capital N by small n. Okay. This is your torque equation in terms of Newton mm, guys. But what exactly the basics of your engineering should teach you, or physics, you should be very strong in such basics, guys. The torque is also given by other formulas. Torque is also given by moment of inertia multiplied by angular acceleration. Moment of inertia multiplied by angular acceleration. This is a knowledge which you should have. So obviously here this angular acceleration usually we call it as alpha. Okay. So I alpha we call this as. This is torque. I alpha. Moment of inertia is nothing but mk square. So m k square into alpha. Okay. Now angular acceleration will be in terms of radians per second square. Radians per second square. So once again, m k square alpha is what exactly? Mass he has given, k value has given, alpha we need to find, angular acceleration. Now what is acceleration? Once again, speed by time, change in velocity by time, yes or no? So once again, change in angular velocity by time. So what is angular velocity? Is not v, it is omega. Omega 2, obviously omega 2 minus omega 1 by time. Time he has given. So I need to know the value of omega 2 to omega 1. Now what is omega 1? At speed n1. At n1, now initial speed was 0. At n1 is equal to 0, omega 1. The formula is 2 pi n1 divided by 60. So this also will be 0. At n2 is equal to 2 is on 80 rpm. Omega 2 is equal to 2 pi n2 by 60. So once again 2 into pi into n2 2880 rpm by 60. How much is this, guys? Omega 2
301.59.
301.59 radians per second. I got this. So I got this value. So let me calculate the value of alpha. Alpha is equal to omega 2 301.59 minus omega 1 is 0, and time is how much we have given? 40 seconds. So 301.59 by 40. How much is this value?
7.53.
7.53 radians per second square. Alpha, you got this value. Once you got this value of alpha, okay. So come back. Okay. Sorry. Once you got this value of alpha, Now I'll try to write this value of mt. Mt is equal to, we have m k square alpha. Now here the other part of the knowledge which is required here is the units, guys. You should not forget about the units. This is in terms of radians per second square. Radians per second square. This is in kg. This is in kg. What should be the unit of k, man? He has given the unit of k in 125 mm. Should I leave it as 125 mm or should I convert it to meters? And mt I need in terms of Newton mm. mt I need in terms of Newton mm. So k should be in what? Hello? You are understanding my question? Did you understand my question? What will be the unit of this? Anyone? Fast. So I repeat, mt is the formula m k square alpha. And listen guys, what I am trying to do is I am trying to talk about the knowledge point of view. If you don't have this basics and if you still feel that you are going to become an engineer, that is not correct. Okay, n should be, I want this n should be in Newton mm. I want this m is by default in kg. Will I get Newton mm if I multiply all this? This will be in radians per second square. What will be the unit of this? How do I get it? Any questions? What should I do? Sanjay?
So I think it should be in meters.
It should be in meters. Sure. What
So
makes
because
made
kg
it
meter per second square is Newton, sir. So
beautiful? This is what I expected. This is what it is required. Kg meter per second square is newtons. First convert it to newtons. You need to, people usually, most of the people will think of mm. It is not the mm. First think newtons. How I should get newtons? Now here 1 Newton is equal to kg meter per second square. This is newtons. So this should be in meter square. Okay. Now this is not mm square. K square is mm square. Now what happens is, see, kg multiplied by meter square multiplied by radian square 1 by s square. So radians uses rotations now. So once again what I do is kg, I'll take meter here. Okay, I'll take by second square and still I'll get meter. One more meter is there. This becomes Newton. I'll get Newton meter. So whatever the answer I'm going to get, this is not in Newton mm, I'll get in Newton meter. Whatever the answer I'll get in Newton meter multiplied by 10 power of 3, I'll get in Newton mm. This is what the concept which is required for you. So once again guys, let me go with this formula. mt is equal to m k square alpha. Okay, so m is how much here? 300 kgs. K square 125 by 1000. Oh, sorry, I'll write down. Mt m k square alpha 300 into 125 by 1000 whole square into alpha. Alpha, how much we have found? Alpha is 7.53. 7.53. How much is the answer, man? How much is the answer? Fast, calculate it. Make it fast.
35.29.
35.29. What should be the unit now? What should be the unit? Let me say I'll also calculate 300 into 125 square into 7.53.
Newton mm.
Newton?
Newton mm.
Newton meter, na? 35.29 Newton meter. To multiply this with 10 power of 3, you will get Newton meter here. See, that is what I have mentioned here. Newton meter. So once again multiply this 10 power of 3. You actually the answer is 35.296875. So 35.296875 is the answer. So multiply by 1000. multiply by 1000. You have got 35296.875 is your Newton. So torque has been given. Now you use all the formulas. Now you use the formula of FA. Okay, you know how to use the formula of FA. Now you know how to use the formula of MT. Okay, now in FA, obviously by default you'll be using the formula of FA. FA is equal to pi dm pb sin alpha. You'll use it. So you know the relation between dm and b. You know the relation between dm and b. Okay, you will be able to solve it because he has given it is b is equal to 4 times or dm is equal to 4 times of b. That is what he has given. So the same problem. This problem is same as question number 19. This problem is same as question number 19. But the question is the way how he has asked the question. The way how he has asked the question, because your knowledge should have a vast amount of knowledge in finding. Not always that you should be able to use 9.55 into 10 power of 6 capital N by small n. There are so many formulas for MT torque. Okay, which formula will be used?